Hi, everyone. Welcome to the fall's first webinar. It's not fall, it's like 30 degrees here, but let's say it is fall. Today, I'm going to talk about refactoring and what it is and how you can do it, even if you don't have any tests. And obviously, it's going to come down to write tests, but that's just a part of the thing. So we can't chat, unfortunately. Apparently, something with the settings that I can't find. Something weird with the recording, but other than that, like Amit wrote in the Q&A, if you phrase it like a question, I may answer you. Other than that, I don't know, let's start. So, welcome to my webinar. I'm Gil. Apart from doing webinars like this, hopefully on a monthly basis, this is what we had until now. I'm also a trainer and a consultant, and I work with developers and testers and everyone who wants some kind of input into writing better software. Also the author of 2 books, Everyday Unit Testing and Everyday Spring Testing. And you can get in touch with me with the things there, email, stuff like that. What I'm going to talk about today, I talked a lot more in depth with exercises as part of my clean code workshop. And some of it also goes into the unit testing and TDD stuff. I'll mention that as well. So if you're interested in digging deeper into these things, let me know, and I'm sure I can help you. I'm going to start with this. This is what I'm showing almost in some fashion on every training or webinar or whatever. This is the goal. This is what we are usually as developers paid to do. We need to create code that works over and over again. The code works. If it works once, excellent. But the over and over again, this is how we develop code. We do it incrementally. We do it iteratively. And we have a lot of practices, including refactoring, that help us in the over and over again part, because we're going to get into this code again, and we're going to do stuff in it, and we'd like to be readable, we'd like to be clean. This is mostly where refactoring comes in. So probably some people are thinking, hopefully not a lot, what is refactoring? It's what I'm going to show in the next slide, but it's not important. Well, it is important for this session. So this is the source of all knowledge from Wikipedia. The process of restructuring existing computer code without changing its external behavior. If you go to Martin Fowler's definition, it's going to be the improvement of existing code without changing the behavior. But as we will see, it doesn't have to be. So yeah, what is refactoring? This is a renaming thing, right? I have a class called train, and I can rename the variable from X to people on train, and I can rename the mul method to max number of people on the right-hand side, and suddenly everything is clearer, assuming that's what I meant. But you see, this is a two-sided error. You can go from the right-hand side to the left-hand side. It's still refactoring. So when we're talking about refactoring patterns, renaming, extracting method, yes, we do it with the intention of making things clearer, more readable, easier to understand and do stuff, like add new features. So we have some kind of intention, and we can do this, but this is like an extreme case, like changing people on train to X is, I'm sure nobody will ever do that. But we can rename stuff or restructure code in a way that makes sense to us, but not to other people. Of course, I'm telling this to everyone who wants to hear. The only way to know that this works for other people is to show it to other people. So do reviews. Except I told them. This is like a very simple example of refactoring. Let's look at another. So this is a quick sort. I'm sure you've quick sorted things before. And we can take this and refactor this to this. Now, the first example with the renaming and simple stuff like that, I used IDs. I'm using IntelliJ for these examples. So IntelliJ was very friendly and was very helpful in changing all the occurrences and so I won't forget and so on. This is another kind of refactoring because, well, how do I know it's actually refactoring? How do I know that I didn't change the behavior? I didn't have any tests. What did I have? I had docs. So if you look at arrays.sort on the JDK documentation, you'll see that it uses quicksort. So I assumed that I can replace this code with another. Obviously, this is a manual operation, right? I deleted everything there and replaced it with this line of code. So how do we know that we're doing refactoring? How do we know that we're not changing codes? So it's really some kind of a risk analysis that we do or we don't do in our brains. So we may think about it, so we just do it. But basically what we're looking at is when I trust the tool, it will do this for me. I'm assuming it was tested by a million people until now. So renaming will just work. It will not break anything. So renaming, extraction, moving code around, which is, by the way, is a bit risky, but the tools become very good at that. But if you'll see that, if you look at the IDEs for C or C++, they have much fewer refactoring patterns they can do by themselves because they can't risk doing all kinds of mistakes. And even in Eclipse, I had the pleasure of refactoring something with conditionals, and it did something for me, but it failed my tests. So we do some. Can the tool do this for me safely? Yes, we can do that. Do I trust the docs like I did? Yes, then maybe you can refactor that. Can I change the code because somebody looked at it and says, well, it looks the same, therefore it does the same? Maybe. If I have tests, do the tests cover everything? Never. So is it enough? So we kind of, refactoring is never safe, really, but we kind of hedge our bets. We put some kind of trust in some amount in our trust box, and then we can say, well, this is really without changing behavior. So what's the problem? The problem is that we don't have any tests. We don't see what's going on. So we can change behavior, and we assume that we don't, but do we? So if we don't have tests, obviously it's going to be a problem. But sometimes even having tests, it's not enough. So I talked about the situation where I have not enough coverage. I know that there's not enough coverage. So obviously, if it's not enough, I won't see all the side effects if I break anything or something that worked before doesn't work again. But there are other situations when we can think about what's going on inside. So here's a very high-level, elaborate diagram of a system. Even my system, no, that's a bit different. But it's a very simplified thing. We have an API that calls the logic, and the logic calls the database. I want to refactor the logic part because I was smart and the API level is very thin and doesn't need refactoring. And I may have tests for the APIs. Let's say this is the situation. So this is like an end-to-end scenario when I call the APIs and it calls from the logic to the database and back. So I have some kind of a coverage here. Well, here's a philosophical question. If I'm going to refactor the logic, I need some kind of observability of what's going on. So the tests on the API level might tell me if I break something, but I only have tests for the APIs. Did I change the behavior of the logic? Because I don't know what's going into the logic and what's going out of it. So I know thinking about refactoring really gives me and other people a headache, because as long as we don't talk about it, when we understand that refactoring is renaming and method extraction, that's cool. Yes, but are we doing it safely? So what I'm going to talk about today is the safety net. Is when you don't have testing. I'm going to talk about characterization tests, what they are, and if you've seen other webinars I do, I talk a lot about them. And characterization tests basically are tests that characterize a system. What is a system? We decide what the system is, what's the boundaries, and so on. Basically, these are tests that take, it doesn't matter if it's unit test, API test, and it really doesn't matter, but they capture the behavior of how the system behaves now. Now, you may not have documentation, and the code may be 5 or 10 years old, and you're kind of push inputs into the system and something comes out. And this something may be what the system should be doing, or maybe it's something that it just does, but is wrong because there's a bug in the system for 7 years and we haven't fixed it. But for us, characterization tests, when they capture the behavior, we can refactor that as long as and the behavior doesn't change, and as long as we accept that this is how it is. And even if it's wrong, but this is how it is. Because I'm going to talk about it at the end. Refactoring is basically working in a stage where we don't add any features. We don't change behavior. And therefore, whatever the system has done before, we want to capture that and make sure that it does just that. So yeah, this is what we want. So we need to be aware of the definition of what's the meaning of failing test here. Failing tests here doesn't mean that the system did something wrong. It just didn't behave the way it was before. And this would be our flag system. As long as things are green for us, we haven't changed functionality to whatever definition of what we did. I'm going to show you examples with a tool called Approval Tests. Approval Tests is an open source library. It comes with all kinds of languages. I'm going to show you examples in Java. It works in .NET, Python, Ruby, Swift, whatever. You can find alternatives. You can find alternatives to Approval Test as a tool called Story Test. If you work in JavaScript, for example, which Approval Test has some kind of equivalent there. If you worked with Jest has something that works with like Approval Tools, which means like template-based testing, which I'm going to show you in a minute how it works. And I'm going to talk about at the end about what not to do with template-based testing. But the tool is very simple to use, and it's very useful in capturing behavior. So probably want to see an example. So let's do this and get IntelliJ on the screen. First, a small example. So this is like the canonical example of approval tests, what we have here. So first of all, this is Java, and this is a Spring project because I'm going to test APIs as well. Approval test doesn't care about that. just a library. I use it in my POM file or Gradle file to get the dependency. And basically what you see here is a very simple test. So I get an array of strings and I call approvals.verify. So this is a JUnit test, only this test doesn't have an assert. What happens when I run it? So when I run this, you can see it here. What happens is that you see the test failed and there is refreshing. There's a file that is being created here. And you can see the file gets called, but the name of the class, the one example test, dot welcome to approvals, which is the name of my test. It's here. Dot received and dot text. Actually, what we should see, and I'm not sure why we are not seeing, hopefully it will refresh in a minute. So the received file basically contained some formatted text that I sent into the approvals.verify all. So I sent a string array. You see, these are the values. It puts in some kind of ordinal numbers. And what it doesn't show me is that it didn't create, or it does create, but it doesn't show me the same thing, same text file with an approved method. So I'm going to just copy that and create an same name with approved. And it's going to probably shout there is a file like this, because although it didn't. No, I don't want to add files to Git. So I have files, this, and now my received file, something that came out of the failing test, now sits very carefully in the approved file. Now, if I go to the test and run it, run, it passes. So basically what we have here is a mechanism that creates an output file out for every test, every approval test, whenever I call verify or verify all, dumps into it whatever I decided to write. And once the output is similar, exact similar to the approved part, the test passes. And that's for me, or for approvals, meaning we didn't change functionality. As long as this is going, everything is great. And apart from creating the approved file for me. By the way, I don't show it today, but it has integration with diff tools, so on. So it can work differently. I'm going to get back to this before going deeper into more examples. But you want to see more examples, right? So I'm going to show you a couple of examples. More closer to the real. So the first thing I'm going to show characterization tests using approval tests for an API, the API level. I'm going to show some of the tests at the unit level. I'm going to also talk about support for the integration level. So I'm going to refactor in a minute some piece of logic that talks to other pieces of logic. And we'll see when we capture behavior, what kind of behavior are we talking about? Obviously, we're going to do some refactoring, not a lot, but enough for you to get the gist of what we're doing. And then I'm going to talk about what happens when I actually need to change the template or change behavior. So I'm going to talk about, if you've seen one webinar of mine, you probably have seen me talking about my messy calculator. So this would be my example. I'm going to introduce you to the code of my messy calculator, because if you haven't seen it before, it's a masterpiece of something. Okay, so let's talk about this. So my calculator, so it's basically an API. So I have a calculator controller. It's a Spring controller. The root API is called calculator. It has a post with press and a request param with a string called keys, and it has a get API called display, which calls the internal calculator for the get display method. So yeah, you're thinking, what do I need to refactor this? Probably not. You see though that this bits of line of code here just feed the calculator one character of it at a time. So I'm sending like a whole string, but it just pushes in because this is a very finicky calculator. It knows how it wants to be fed. So this is my calculator. And you can see a lot of things here, including if you know smell names, code smell names, you might have hit upon arrow code. This is a sort of an arrow code. So if you got like if like something going like this is arrow code. It's like shaped like an arrow. And obviously it has a lot of applications here, and that's something I'd like to take care of. What else do we have which is important for later is my calculator works with something called an external display. It's an interface, and my calculator basically has like the press and the get display, but it also works, you can see here, that it pushes the results back to the external display every time. So this is important for later. We're going to start with this. So if I was writing real tests, okay, let me they will probably look like this. So this is a Spring Boot test. It works with configuration. So I'm working for today with a real calculator controller, something that will tell me answer the APIs, a real calculator, but a mock external display. I'm not going to talk to hardware today. How do the tests work like? This is a mock MVC test. If you don't know about Spring tests, read about it. It's very interesting because they give a very good foundation for doing something like a unit test for controllers and whatever goes in it. And this is basically what happens here. I'm building mock MVC, which is kind of creates a controller server, a web server that loads the controller, and it runs inside the process of the test. So when the tests talk to it, it can with API language, it gives back responses and so on. It's very nice. If you're just working with just calling servers, this is much more nicer, isolated, and so on. So basically, I'm testing my calculator. And like I said, these are real tests. So if I wrote real tests, I would write a thing that is very readable. It starts, it should show 0, and pressing 3 should show 3. Obviously, I want to call the API, so at start doesn't do anything. It's just for readability. But pressing calls the press API with whatever I send it, the entire set of characters. Blah, 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 blah. Post press the entire keys as a request. And I'm getting something back. I'm not saying other than the status. It's a post. I don't expect something back. And the should show basically calls the get display and gets the result out of the response and asserts on that. So if I would write real tests, it would look like this. The problem is that this is a messy calculator, not so much of a working calculator. And some of the behavior inside it, we consider a failure. So if I press 0, 3 in my calculator, it should show 3, but it doesn't. Yeah, if I run it, you'll see that I think it shows 0, 3. It's not production ready yet. You saw it ran the entire Spring context and tells me that I expected 3, but it was 0, 3. So yeah, it's not ready for production. But surprise, it is running in production. So this is something that we don't want to break. We don't want to change functionality. Okay, so this is the beginning. How do characterization tests look like? Well, the operation is similar, but I've made a couple of changes. So still the same controller, still the mock MVC, still loaded the same way. Only this time I have a string called calclog, which I start pushing things into it. So the test may look similar. This time I put at start, and instead of should show, I'm using capture result because I'm not asserting. And you see that I piled over also the successes and the failures into the same chunk of tests that I'm going to run. And whatever's at the end of the calclog, I'm going to dump into approvals.verify, and this will create my template. How does it look like? Well, the pressed, I just added some kind of logging here. At start, some logging here, and the capture result is a bit different. I'm still calling the calculator/display API and extracting the result and just logging it. So if I run this, this is the received file for all the tests that I've created, and I can create an approved from that, and I can refactor because I'll be sure that I don't change anything, right? That's right. These are 3 tests. If we really want to do something more safe, let's call it, I can dump a lot more cases here, and I'm going to do the same thing. Same logging, only with different cases. So it doesn't work and creates a better log. So the more things I dump into that, the more I understand how it's working. For example, I know that my calculator, it's messy, but it supports plus and div. But so I didn't even do minus in here, but if I was able to do that, I might do that. So I can take that and refactor. What else can I do? Well, I worked at the API level. What happens in the calculator level, the component stuff? I can do the same thing. Only it's a bit different. Remember, this is a real unit test. It's not a Spring test. I'm testing the calculator. If you recall, my controller, what was it? My controller was feeding the calculator with the string that I sent it, and just ripping it apart and feeding it character by character. Now I need to do that. And that's like a reminder that whatever goes inside doesn't have the same, it has some kind of processing before input gets into that. So this time I have to supply this kind of input if I want to. So in my unit tests, I basically have something that looks similar, but I need to supply some kind of pressing mechanisms. I could do like press, but this time I'm using a helper method in my tests rather than in my controller. And for the people who were quick to see, I hope you were quick to see, this is not the same implementation as I have in the controller. It doesn't have to be, because I can't really rely, or I can rely, it doesn't really matter, but tomorrow the things will change. The test doesn't have any contract with the controller, so I can feed it this any way I want, and basically it does the same thing. If I run it, create the same received, should also create the empty approved, but it doesn't, because it doesn't. This works. Why does it work? Because I put the approved here. Okay. This is from the before. I'm going to talk about using the pre-approved files. So it creates this. I can refactor stuff. Let's do some refactoring. So let's go to the calculator. What should we do? Well, you see that the error code is something that I don't like. So I'm going to introduce guard clauses. Guard clauses means that I'm going to return early. And it's a good way to get rid of these things here. So if I've gone into the plus thing and I return, I don't need the else. So I can remove this, and I can remove, I think, this. Don't know. Did I did it right? My characterization test will tell me. I run it. It's green. Okay, can continue. Let's do some reformatting. Have I done it right? I don't know. Let's run the test. Small steps running every time like regular tests. And it will tell me what's going on. What else? I can get rid of this else as well. And you can see that I have some kind of an intention, not just ruining the arrow. It's going towards some kind of a switch statement. So this didn't have any brace. Let's see if it still works. Run it. Yeah, excellent. And the minute I break stuff, something, let's introduce something, a problem, a minus instead of the division. Let's run it again. Oh, something is wrong. And this is a number exception. So this is problem with the browse int. So obviously something went wrong. It didn't even get to the part of the log itself. Let me see what I can do. Let's put a 1 here. Okay. And run it again. So we'll see something in the log file. This time give the test and the code a bit of opportunity. So we ran it here, and you see it creates a received and it creates a different behavior. And you can see that at pressed C0 at the approved level, what it should be or what it was before. At the received, it shows 1. And basically, it compares the two strings together. It could be like massive files, right? It says they are not the same. So we don't want that. We're refactoring. So we actually want them to work correctly. Let's go back to controller, to our calculator, sorry, and fix that because we don't like things to be different. So it's here, it's 0. Let's see if everything went back to being everything as it was before, as history taught us. Excellent. Okay, so this is like the process. This is how you do refactoring, step by small step by small step. Don't do big steps. Do big steps, something will break, obviously, but you wouldn't know which part broke it. So this kind of thing helps you do a step-by-step thing. Now, I talked about what is functionality. So as long as we're doing like looking at my calculator read from the two APIs, we'll think, well, we kind of covered whatever it does inside. Not completely. So for now, all I did, remember the external display, I mocked it and I said it's a regular mock without any behavior setting. So that means when this line gets called, external display is on returns false and we don't do anything. But if is on is true, this method gets called. And I want to make sure that what gets sent to its dependency, the external display, is the same thing, because this is kind of a behavior change that I don't want to break also. So think about what we're talking about. When we're talking about black box, it's not just from the API level, and whatever goes on inside there, it's okay. It may not be, especially in integration level when our component talks to other components or services. So I want to capture that as well. So I'll show you a couple of ways. One is the more controversial one, which is change the code. Okay, so how do I do that? So you see, I just kept something here called a logger. And I want to capture whatever's going in inside. So when it goes outside in this line, I'm going to introduce logger equals get display. And now that I have this logger, which is public, in my tests, I can capture it here. So I can reach inside, get the logger, and apart from the mocking part here, I'm doing the same thing. You'll see that these two don't work. They break. It's not, we don't get to the log level. Now, I've changed the code for the tests. Is that okay? Remember the risk analysis I was talking about earlier? We're doing the same risk analysis. Is adding logs, and it could be like passing a logger inside the code and let the code use the logger just for the part of the refactoring. Is this okay? Well, it depends on what I'm doing. If it's going to be timing sensitive, if it's going to be some asynchronous code, no, it doesn't make sense. I'm going to break something. But if it's not, it's okay for the refactoring session. So this is one way to do it. And you can run it, see what's happening. And remember, this is not checking the get display method of the calculator. It checks whatever the calculator sends to the outside. So yeah, it created a received file. This is what gets sent. And this, I can use this as an approved file to check also what's coming out from the other side. Now, this is like the change the code. So what if I don't want to change the code? I can use Mockito for that. It's very cool. So in my, let's go to the calculator, remove my logger. I'm going to keep this so it can compile, but I'm the block I'm going to return to its old glory, like it was before. So I'm using Mockito, and Mockito has something called an argument captor, which I'm going to show you. It's a very cool feature that captures everything that's going through what gets called on methods and mocks. Basically, it looks like this. So these obviously still don't work. But at the capture sent, I'm using argument captor. It's part of Mockito. I'm using verify argument captor as a factoring method called argument captor.for class. What is the class? The method is show, and it gets passed as an argument of string. So it's going to be string. And we use verify, Mockito.verify to fill it up. So the syntax of Mockito with verify is the mock. I need to pass at least once because it's going to be called a lot. But if it's not, that's a problem. Verify.show, the method I'm checking, and it has a single argument. And at the place of the argument I want to capture, I'm using the send to display, the captor.capture. And when I did that, and remember, this is after the method call, after show was called, and in our test, it gets called a lot. I can go to the captor and ask for get all values, everything that was sent. And I can take this, what it returns, either get all values returns list of string, get value returned once. But we know that this is for every string of characters, we expect show display to get called. So it's a list of string, all values. I'm using them to create the entire thing. And then I get, when I run it, I get something like this. This is a proof file of this. I don't have the two at the top. It gets something similar. You can, if your keen eye sees it, there are bugs here. Okay, so this is the part where I talked about at the integration level and what I can do in order to maintain functional behavior at the other border. Now, obviously, having these kind of tests here, don't like them. These are bugs. I want to fix them. So let's fix the bugs. Now, I'm going from refactoring mode to changing behavior mode. That means that after I get back to refactoring mode, my template may not be worth anything. They may be worth something, but I won't be able to prove that. So I'm going to change behavior now. And that means I need to put aside the templates, the approved files. I am going to write tests, obviously, because I'm smart and we need to do that. How does it look like? So I have two tests here, and they are in the integration level. Remember, the behavior works okay, but the problem is with the integration. So the first test was that showing 0 on start doesn't work. It doesn't get passed. So, and the second one is showing 0 after C. So I can run them and prove that they don't work. And now let's fix it. This is, remember, this is an assert. This is a real test. I'll go to the calculator, and at the beginning it doesn't show 0. So let's call external display dot show with get display. This should take care of first one. Yes. And now showing 0 after C. External display dot show get display. This should take care of the other one. Yes. Okay, great. Now the behavior. This is the old the behavior part of the calculator, the unit, but calling the API as the get display. But the integration level, look at it. It doesn't have the writing of the first two tests. So currently, I've changed my tests. Now they are working. But if I run this with the old approved file, there's going to be an error. And because there's an error, this is the point when I say, okay, is it okay to take the new template? Because I did this and I know what I did, and now I added this kind of logs, I can say, well, I'm going to accept the entire thing. So I'm going to copy that into my approved file, basically replace the entire thing. And now I can continue to refactor because this now passes. And that's the process. Okay, going to get back to my slides and close. So a few things. So what did we show? We showed that how to create characterization test APIs at the API level, and the unit test level. And they don't have to be the same, and they can complement each other, and they probably want to complement each other. But it's really about understanding what is the system that we're refactoring and what might be the different dependencies that might be affected. Because when we define no behavior change, we need to define what is the behavior change. And this could be like completely blindly behind the APIs, or it may matter to us because we're talking to services, or we're setting up global data or static data that may be shared by different other components, because my component may be changing, but in this kind, and my API calls this component, but somebody else's API may call this component as well. And what am I maintaining here is very important to define. So we talked about the integration level, the boundaries of what we're talking, how to capture that as well, or capturing inside it. We did a bit of refactoring just to show how the process is, and what happens when we need to change the template. Now, can we use these tests characterization tests as real tests? Well, the answer is yes, technically yes. The tests, you just have to put the approved file near the test class, and JUnit will run it, and approval will look for the file and tell you if it's different, and fail the build if you don't want to. But the problem is that the assertion is not a very specific assertion. It's like the whole bunch of text here is different. And if you're working with big JSON files and large responses, stuff like that, there are going to be multiple things that are going to break because you broke something. And then finding out what was the problem without asserting like this field should be 3, except you're looking at a bunch of things and it here 3 is 5 and here 6 is 9 and there 17 is GIL. So it's possible to use them as real tests, but if they fail, they're not going to be as useful as tests with assertions. So we're losing information about that. But if you don't want to throw them away, as long as you're not changing behavior, that's cool. Remember that that's the problem. If you remember the first bug we started with, don't remember even what it was, with the failures. If you want to go fix that, the approval test will fail because you change behavior. And this is something that we need to be aware of. We need to understand why it is failing. Which leads me to the next question, which I see many times a lot with people, front-end people working with Jest, who's just as easily change a bit of code. I said, obviously my template has changed. I'm just going to replace it. And that may be a problem because just replacing the template, because obviously it's going to change and it may have changed, it may hide bugs in there. So my suggestion is just not use template as much as you think it should be. Use real assert as much as possible. Now, I mentioned it a lot in different ways that this kind of 2 modes of working. One is the refactoring bit when we don't change functionality. The other one is when we do change functionality. And obviously, not first of all, it's not obviously. First of all, this is something that whatever you're doing on whatever level of, you're a junior or a senior, it doesn't matter. Be mindful of what you're doing now, because the expectations of what the results are and what your side effects are, you need to be aware of them, and it starts with you knowing what you're doing right now. And it's easier with, obviously, with tests, but when you do stuff without tests, refactoring without that, you should know that as well. And it kind of lead me to something that's very similar to that, which is TDD, test-driven development. Test-driven development has the separation between function and form built in. The green part is where you change functionality. You add functionality according to the red test and says, oh, I have new functionality. And once everything is working and everything is green, you can refactor. It's very smart. So it's good to be that, and by doing TDD, and I really encourage you to do that, you kind of build this skill in. Plus, you have better tests. Now, to summarize, we refactor all the time. We refactor as part of, before we do changes, after we do changes for clarity, before we do that in order to prepare the code. We do it as we work. So we do all the time. And what we're trying to, we should remember, is that what we're doing is risky. What worked before may not work again. So we need to support ourselves in different ways. Obviously, the best way is to write tests. The best way for me, I think the best way is to write tests. But even if you don't have them, we need to minimize the risk factor. And in order to do that, we can use characterization tests and approval test or jest or whatever framework you're using, but keep in mind of what you're doing, because the results are going to be interpreted in a certain way. So the separation between functionality and form is very important. We need to know what we're doing. And whatever we're doing, if we're trusting ourselves or the tools or other people, these are also forms of risk reduction and risk mitigation. So we need to do that as well. That's why I really recommend doing code reviews. The more complex it is, the more eyes we need. And the tools will help us in a certain way. The processes will help us in a certain way, but we need to cram them all together so we can rely on the result. Saying, well, this is a better code and it still works. And I really encourage you to go check out approval tests or any template-based tools and see what's happening. And that's my story for you today. Yeah, you might have any questions, so this would be a good time to put them in the Q&A box, and I'll try to answer them less sarcastically than I'm used to. So this would be a good time to write it. At the end, I want just to show you different ways to contact me via email or LinkedIn or Twitter, Instagram maybe, or you got all these kind of pictures going there on Instagram. So go to the site, unitesting.com or testingguild.com. You'll see past webinars and recordings. If you're going to JCon next week, JCon Online, I'm going to be there presenting two talks, and we are developers as well on Java Day. Going to be a heavy week. There's no questions. Oh, one question. When should we accept technical debt? Ooh, that's a whole webinar by itself. Okay. Let's define technical debt, not like regular people what is technical debt? Technical debt, and I like Ron Jeffries' definition. It's not just Ron Jeffries, but he's the one I'm reading right now very excessively. And basically it's taken from Ward Cunningham's, the one who coined the term technical debt, is basically the distance between what the code was, the design was when we have written it, to how we look at the code now. So it's not about the code, it's how we look at it. And we've learned stuff, we know what's working, what's not working, how we use this part of code and this pattern is somewhere else. And we look at the code today and say, it's missing something. It's not readable, we want to refactor it, it has error code, it's messy, stuff like that. We want it to be here, but it's here. So now what do? We can do a lot of things. We can just say, well, this code doesn't change. It's working. We're not going to touch it. It will stay like that. We can say, well, we need to fix it. We're going to go to change that code anyway because we need to fix bugs or add functionality, and then we're going to do this do the changes, whatever the changes are, on the way. Or you're going to say, oh, this requires a whole rewrite, what I did with the quicksort. So this is a whole new project with the risk involved. So should we accept technical debt? Yes, why not? Because it's a risk analysis thing, right? Is the code going to be used by many people and it's going to lose for all these people a lot of time? No, well, then we're going to refactor it. So we need to ascertain not the technical debt, but the tasks at hand. And we are going into this code to modify it in some way. Let's do some refactoring on the way. We're not going to touch it. Why the hell should we go in and break stuff? Why do that? And technical debt is not something that Jira tells you in terms of hours or whatever. It's not. I don't know how they came up with a number, what the number is based on. Don't believe Jira's lies. You can't really, and after the 15 hours that you managed to put in and fix the technical debt, hey, surprise, tomorrow you look at it differently, and maybe Jira with its new version and new rules will look at it differently as well. So you can't really ascertain or estimate technical debt. You can't estimate really development task. We guess, we do all kinds of things, but the estimation is very bad because we're humans, and therefore take it with a grain of salt in terms of what you're going to do. Again, it should be, are we going to touch it or not? What's the risk of touching it? And if it's not, if you're doing like in a pair and you have tests around it, fix it. Why not? If you have the time. If the risk is high, you should really go in knowing what you're going to do. Right, another question. Any tips on how to get management to acknowledge that QA's automation is not just test code and should have the same care standard scheduling as real production? Of course, put bugs in it. Very easy. Like in production code as bugs, now you have to work on fixing your bugs too. It's real code. Everything about standardization that we have in production code, we should have in automation code because it is code. If you can't, I understand where the question is coming from, but it's that it starts with this. You're code professionals. You're writing code, and code has to have standards with quality, with readability, same as everything in production. If you're going to refactor the code, it's because you think the code is not good enough, and you've taken into account all this kind of risk analysis thing that I was talking about. So this is part of your job. If your manager doesn't understand your job, that's another problem. It's not you're going to convince them. Like if they were not aware that your coders before, you're in a bigger pool of problems that then explaining refactoring to them. So that's the basic line. When you're working on something, you're a professional in that thing. You're writing automation code, that's code. That's the standards. You have standards for code. Production code, the same thing and the same standards. Can't help you with that. Okay, so that's the questions that we had. Last chance to have questions for me. No. So if again you can we wake up in the middle of the night, you say, I have questions about refactoring. Yeah, don't call me up in the middle of the night, but you have these ways to get in touch with me. I promise, sort of, if the sun is outside, I'll probably get back to you. Other than that, have fun and enjoy the rest of the week. And until the next time, goodbye. Hey everyone, if you enjoyed this video, be sure to like, share, and subscribe for more. Thanks for the support, and remember, live long and test.